Hello everyone, my name is Sophia Stavala and I will be discussing the history, usage, and the global impact of powder metallurgy. So just a little bit about what we're talking about today. First, I will just be discussing what powder metallurgy is, as well as like the history of it. Next, I will discuss about the process of powder metallurgy itself. And then I will talk about it more so like globally, as well as eventually concluding the presentation. And if this was in person, I would ask anyone have questions, as well as like show my references. So first, we're just going to start with the introduction. So what is powder metallurgy? There are a wide range of ways that parts can be made with metal powders. These methods are used in a variety of industries and fields, and it is growing in popularity. The metal powders are especially useful because they can help with increasing or decreasing properties in order to have the desired effect for said product. The most popular powders that are normally used are red and black cupric oxide, nickel, aluminum, tin, and copper. So because of how widely used powders are, you might not actually realize what some metal powders are actually used in, and it's kind of interesting. So I'll just be going over several different examples. First is aluminum. It's a very versatile material and it is commonly used for fireworks and pyrotechnics due to flammability. It can also be used for metallic paints and manufacturing of solar cells. Bismuth is commonly used for alloys such as steel or aluminum, as well as production for batteries and welding rods. Cadmium oxide is used to create silver alloys, glazes that are used for both ceramics and plating steel, and the production of transparent conductors, semiconductors, and nickel-cadmium batteries. Granular copper is commonly used for self-lubricating bearings, injection molding, lubricants, and coatings. Iron powder can be used for machining, filtration, and the makings of magnetics and magnetic products, as well as like printing and friction products, such as like brake pads. Manganese powders are used for steel and iron industries in order to create alloys for the manufacturing of tools, machinery, car parts, and construction. Nickel is used normally combined with steel and iron in order to help with corrosion resistance. Red and black cupric oxide is normally combined with copper for wood treatments and any pigments that are used in glazes and ceramics. M and SW grade tin powders are normally used in spray-on applications, which normally for corrosion resistance. Also used to make high-powered magnets and self-lubricating bearings. Similarly to aluminum, zinc is also very versatile, and it's commonly used for galvanized steel or brass, as well as different types of paints and precision die casting, plating, and plating of other metals. So now we're just going to talk a little bit about the history. In the very beginning, people would simply hammer the powders. This is much earlier on, but mainly using enough pressure in order to ensure that a solid shape would actually begin to form. The first tracked use of powder metallurgy, though, was around 3000 BC. It was seen that Egyptians would use the iron powder in order to make objects. Similarly, in Central and South America, it could be seen that people would use platinum or gold powders in order to turn the objects into the powder into jewelry. This was a similar method. Powder metallurgy was a similar method for Indian craftsmen with the Delhi pillar. This was estimated to be built between 35 and 414 AD, with it being roughly 6.5 tons. In Europe, records began to show that this process was actually used in Spain in the 18th century and England and Russia in the 19th century. Modern powder sintering actually began in the late 19th century, which was roughly around the time that electricity was first invented. In the 1920s, people actually began to use it to make tools and self-lubricating bearings, and the 1930s allowed for magnetic materials. Germans began to make firearms in the 1940s with it, and car parts were made after World War II. Powder metal processes were used for metal injection in the 1980s and additive manufacturing in the 2000s. And then just a couple of pictures on the right, just showing what was actually made with it. So now we'll just be discussing the process of powder metallurgy. Alloys are first processed so that they become a fine grain-like powder, where it is then blended with other alloys. It is through this process that we begin to gain like the desired material properties or characteristics that we would need for the product. This allows for great flexibility as well as like customability as well. The metals can be powdered through solid state reduction, atomization, electrolysis, or chemical treatment, such as oxide reduction and thermal decomposition. It can be blended with metals or alloying agents, such as lubricants, to reduce friction or increase fluidity. The powder is packed into the desired geometry, which can be shaped through dies, punches, or like even hydraulic presses. The parts that are normally formed through a combination of heat and compression, where it is able to help improve the strength of it. Secondary treatments can be used afterwards, depending on the product itself. Some of these include heat treating, machining, impregnation, or finishing. On the image to the right, this dictates the process of powder metallurgy. First, the powder is actually gathered and then mixed and placed into the compacting machine. Meanwhile, any additional tooling could be used to reach the desired shape. Next, the product is sintered, and which would then result in the final product. So I'm going to show a quick video, basically showing the compaction process, just so you have a better idea of what it's like. And as you can kind of see from that video, it just shows how repeatable this process is as well. Okay, one of the most common process methods used for metal powders is atomization, and normally this refers to like a liquid form. The metal is commonly broken up into droplets through exposure of water, air, or inert gas. If water is used, this can lead to irregularly shaped particles that are normally pressed. Centrifugal force is another atomization process, where a spinning disk breaks up the metal powder. Heat treatments can be used to change the properties of the metals, normally through softening or hardening the metal. Sometimes only the surface needs to be heat treated, while other times, in order for the heat to impact the entire piece, you would need to wait for the metal to reach temperature before the heat treatment actually starts. For example, I had previously done work at the foundry where I took a sample of an alloy where I basically had to wait 20 minutes for the sample to reach temperature before actually starting the timer for heat treatment of 2 hours. So like for example, overall the heat treatment process took 2 hours and 20 minutes, including the time that it took for the metal to reach temperature. Surface treating depends on the purpose of the product, specifically corrosion resistance, which would act as a barrier for the environment, or barrier protection, or galvanic protection, which are films to protect steel against sharp objects. There can also be thermal spray coating or vacuum coating. In order to determine metallography, optical microscopy or electron microscopy is used. Metal testing can then be performed for the desired features, such as yield stress, elongation, hardness, and toughness. So there are several different advantages to this process. This includes allowing for waste materials and costs to be effectively reduced, even using up to 97% of the original material, being able to alter the properties through factors such as the powder type, particle size, and sintering conditions, producing complex parts, skipping the finishing process, and being reproducible as well. However, with many advantages, there are also like several disadvantages, such as not being able to produce large complex shapes and it not being very cost effective to create small amounts of the product. as well as density changing depending on how the part was condensed as a whole. So these are all types of things that you actually need to consider when deciding what manufacturing process that you would want to do for your product. So next we're going to talk about powder metallurgy, like globally. So currently, the global metallurgy market is growing through several different industries. This is one of the reasons. It's just simply due to natural gas and crude oil exploration. It's helping to increase the growth as well as competitive pressure, new metal fabrication and repair technologies, and new equipment and supplies. Powder metallurgy is also gaining a lot of interest for medical, biotechnology, and healthcare fields. However, it did slow down a little bit just due to the coronavirus. Throughout all of the fields, it experienced lower than expected demands, declining roughly 2.2% in 2020. During this time period, there was also an irregular demand with a focus on industrial services, operations, and repairs, leading to problems with business goals. During the pandemic, automotive companies, an industry that commonly uses this manufacturing process, had to close their facilities or lower the production capacity due to the decreasing amount of materials or the reduced manpower. Now that the pandemic is over and society is relatively back to normal, there's an increased amount of spending, allowing for the automobile industry to grow once again. This industry also uses powder metallurgy for additional processes like laminate molding, metal injection, cutting, and welding. The US is actually roughly like 35% of the global market, and it was estimated that it would reach 1.1 billion at the end of 2022. It is here that there is a solid demand for metal powders, both for steel and additive manufacturing. Meanwhile, China is projected to earn $461.1 million at or before 2026. Canada is expected to increase by 5.3%, while Germany and Japan are following close behind at 4.7%. Germany is actually influencing Europe, mainly in the electrical, automotive, and healthcare industries. Europe itself is just like growing dramatically due to the increased consumer awareness and the focus on environmental sustainability, especially with how eco-friendly this process is for the reduction of waste. For the Asia-Pacific region, it is estimated that it will undergo significant growth, with China, Japan, India, and South Korea being the reason that this industry is able to grow in this respective region. This is especially true for China because the country is well known for manufacturing, being the original manufacturer for several parts, automotive-wise and electronic-wise. It has a large number of manufacturing sites, both medium and small. With an increase in demand and making it easier to deliver parts, it's estimated that the Asia-Pacific region will be key for both Europe and North America in various industries. This graph, as the title suggests, depicts the market share of powder metallurgy through the various industries globally. Although this might not have the full percentages listed, it can be seen that the largest industry that uses this manufacturing process is the automotive industry, with the smallest being related to electrical and electronics field, which correlates with the information that was discussed previously in this presentation. The website that I obtained this graph from, Fortune Business Insights, stated that the automotive industry share would continue to grow. Powdered iron is commonly used for this industry. With the increase of vehicle production, especially with more green vehicles being encouraged to be produced, powder metallurgy will be used for particle metallurgy, hot isostatic pressing, sintering, and injection molding. Meanwhile, this graph mainly focuses on the US part of this through the same industries. Although this might, once again, have the full percentages, it can be seen that the largest industry, once again, is the automotive industry, with the smallest actually being miscellaneous fields. It is very interesting to see how it differs compared to the global market share. The medical field is a little bit smaller in the United States, roughly the same size as the electrical and electronic field. The miscellaneous field, although the smallest field, is roughly the same size as the global market share for miscellaneous as well. Then these are a list of some of the companies that Fortune Business Insights thought were some key players of the powder metallurgy market. It can be seen that the majority were from the United States, with a couple from various companies in Europe, especially in Germany. In China, the modern usage of powder metallurgy actually first began in the 1950s, and like over the past 50 years, it became one of the countries that were using the process, learning how new materials and techniques could be used. China first started this manufacturing process with copper-based bearings, which were made by the Shanghai factory of textile machines. Iron soon followed in the 1960s. New technology was introduced in the 1980s, such as high-precision presses and advanced sintering furnaces. In the early 2000s, the amount of copper parts actually increased very quickly. China also has various industries which uses it as well, such as cement and carbide, which began to also like around 1958. Although that also increased in size, especially with manufacturers that use tungsten, these products range from metal cutting mining tips and wire dyes, as well as other special and large products. Some other material industries include refractory metals, magnets, and friction materials. How was it able to grow so quickly in China, though? They focused on education for professionals in order to ensure that research was performed in order to learn about new techniques and materials that could be used for powder metallurgy. The government also wanted to focus on the technology and materials being worked on by many research lab divisions, and even encouraged the creation of several specialized powder metallurgy institutes. Although China is still behind the US, it is still gradually increasing its products, learning more about the manufacturing process. Similarly to China, people in Germany are focusing on growing their powder metallurgy field. This is mainly through a joint committee which involves the German Materials Society, the German Ceramics Society, the Steel Institute, the Association of German Engineers, and the Powder Metallurgy Association. Through this committee, they are able to schedule events and lectures, allowing everyone to learn about the process. The main goal of this committee is to be able to promote work that is done in the powder metallurgy field. This includes initiation and promotion of contacts, regular exchange of experiences being performed, information about public research funding, conception, organization, and monitoring of joint research, organization of events such as lectures to report on the status and development, as well as recognition of special achievements. So just as a conclusion, powder metallurgy is a type of manufacturing process that, although it might not be widely known, is used for a variety of different purposes and products. However, interest is growing, and there seems to be an even larger emphasis on using this process in order to find new materials and come up with new techniques to make it an even more ideal manufacturing process. Traces of powder metallurgy can be seen thousands of years ago. However, it is catching on in Europe and the Asia-Pacific area, although it might have slowed down due to the coronavirus. Powder metallurgy is useful because of the complex parts that can be made from it, as well as allowing for minimal waste. There are calls to action for companies to reduce their waste and to have more environmentally friendly processes, with companies pledging to become cleaner by a certain amount of years, so this is an especially useful process to use. It is able to cut down their costs significantly as well, just simply using the powder metallurgy. Globally, it can be seen that each country uses this process differently, with more emphasis on some industry fields as opposed to others. However, the one thing that they seem to all have in common is that they are growing in this field, encouraging more research and learning to occur, whether it be through additional funding in China or forming a committee that allows for continued learning in this field. All in all, it can be seen that powder metallurgy is making its impact, and it will continue to grow in interest, and also it will be interesting to see what other advances it will make in the future.